Welcome back to my channel. I'm Brian Kafaki and welcome to a new series which I'm calling the second edition. The series is called Master Databricks. It's second edition because it will eventually replace the Master Databricks and Apache Spark series I did, which is about 40 videos. So it's a lot to replace, and let me jump in and explain why I'm doing a second edition. The original series I did said Databricks and Apache Spark, and I started out in that series doing kind of a mix of Databricks, then I would show you how to do things on open source Apache Spark. In the end, I realized that since Apache Spark is a subset of Databricks, which I'll explain more in this video, it didn't make sense to keep jumping between the two. So in this series, I'm going to stick to Databricks only, but realize that anything that applies to Apache Spark will apply to Databricks. The other thing that has happened in the several years since I did my last series is that screens have changed, features have changed, so some of the things I talked about in the original series are updated, and you need to get the new content on that. So that's why I'm doing this. We'll start out with what is Apache Spark, what is Databricks, scale up and scale out with Barry the Weightlifter, and understanding Apache Spark and Databricks. Then I'll talk a little bit about the Databricks workspace and user interface. So let's start with what is Apache Spark. Apache Spark is an open source big data analytics platform, and meaning open source, it's free, you can install it and use it wherever you want. Now when I talk about big data, I want to be careful because it sort of implies that we're talking about massive volumes of data, which is very often the case when we're dealing with these kind of platforms. However, we're also talking about streaming data, unstructured, semi-structured data, images, video, and sound. So big data is a sort of general term which really represents any kind of unusual or difficult to normally handle data. Apache Spark is a bring your own tools environment, meaning you don't get a lot with it. You get the scaled out platform, but not much else. You don't get notebooks, you don't get any kind of code editor, you don't get any sort of scheduling tools or orchestration. It's very bare bones, and it has very weak support for collaboration. And finally, it's not optimized for the cloud. So at this point in time, really everybody seems to be going to the cloud and doing their work. And since Spark was not designed for the cloud, you're not getting the best performance there. So enter Databricks. Databricks is a commercial product from the creators of Apache Spark. So this was their way to monetize on the open source Apache Spark project. And there's a sort of dual maintenance going on. There's the proprietary side of Databricks, which Databricks maintains, but the personnel at Databricks also do a ton to maintain the Apache Spark open source project. And most of the features of the data platform itself are actually open source. And often I'm surprised to see that Databricks will take something that started out as proprietary, definitely a value add like Delta Lake, and they put it out and make it open source in Apache Spark, which is a really nice feature. So I will say that I think Databricks has a nice balance between giving people something free like Apache Spark, but at the same time making money on their side of the product by adding a lot of value. Now, unlike Spark, Databricks is a complete, comprehensive development environment that's riding on top of Spark. It has numerous proprietary services and features. Some of these, for instance, enhance performance, make it faster, make it easier to use. And so it takes Spark, which would be kind of crude and difficult to use, to be honest, and makes it really a nice experience. It is ideally suited for team collaboration. And there are many development tools. For instance, it gives you notebooks and orchestration tools and even an API so that you can call things from outside Databricks. So a lot of good things there. And unlike Spark, Databricks is optimized for the cloud. Not only is it optimized for the cloud, but Databricks can only be used on the cloud. You cannot run Databricks on-premise. And you can see here the major three clouds, AWS, Azure, and GCP, all support Databricks. Now, arguably, I believe Azure is the primary platform to Databricks. Even though Databricks started on AWS, Azure or Microsoft really embraced Databricks early on when they adopted it, and they promote it very heavily. So when we think of Databricks, you can think of this sort of circle here, and Spark would be a subset of Databricks. So I'm using this sort of Venn diagram. If you've done relational database stuff, you've probably seen these. So within the superset of what Databricks offers is the subset of Apache Spark. And that means that anything I say about Apache Spark is true of Databricks. But since many things in Databricks are not available in Apache Spark, I cannot say the same in that direction. Now, to start this series, I need to explain a little bit about what scale out means. And to do that, I'm going to talk about what scale up is, what scale out is, and I'm going to use Barry the Weightlifter to help us with that explanation. So scale up is the traditional thing that's been around since the beginning of time. You probably know it yourself. You've got a laptop and you say, it's slowing down. I need to get something beefier, more memory, faster SSDs, whatever it is. So you may swap it out and get a more powerful machine, or you may add things onto it. So this idea of just beefing up a single machine, and the key word is single machine, to be more and more powerful, is called scaling up. And for relational databases like platforms like Oracle or SQL Server, this has been the approach for like decades. The machine just gets a little too sluggish, too slow, and they would get bigger and bigger machines, more memory, faster throughput, faster everything. And that worked for a long time. But at some point, you just can't do enough work anymore, and you need to figure out a way to scale out. What's scale up, Brian? I don't understand that. Well, if you think scale up is one person, imagine scale out as being, let's let a team of people work together on the problem and see if they can't solve it faster than if we just have one person doing it. So the idea of scale out is that we now can share the work that needs to be done among a group of people, and they don't have to be heavy duty resources like Barry here. They can just be average people, think average computers, and they can do the work. So let's look at an example. Imagine, if you can remember back, there used to be a thing called a phone book. And the phone book was this big tome that had everybody in a state, typically Rhode Island, at least where I grew up, they could do the entire state in one phone book. And in that phone book, organized by the people's last name, so A's would be all the A's, people start with A, and then B, C, D would be in the phone book. So it's all sorted by the person's last name, and you would go through this to find phone numbers, and you could usually also find the address of the person. So imagine we have a problem. We want to look through the phone book and find anybody who lives on the street that is named Main Street. We need to feed that to our group. How can we let them all work on this problem at the same time? Solution: we'll break it up into chunks. And as an example, let's say we take the phone book and give all the names that start with the letter A to Melanie, all the ones that start with B to Beth, all the ones that start with C to Charlie, and just kind of imagine you do this for every letter of the alphabet. Now you tell the people to start searching. Well, since each person has a small subset of the total phone book, they're going to get through pretty quickly. And so they'll search through and find what they can, and they write down the names of people who live on a street called Main Street, and they will hand it to the person, we'll call that the team lead, asking for it, and they'll hand it back to them. And that person will collect the sheets of paper from everyone, and the task isn't done until everybody's finished. So one thing we can see in this is that the person who has M is going to have a much longer job than the person who has X. So this isn't equally distributed, but it's a good approximation, and it'll be a lot faster than having Barry do all the work. So here we have it, and this is not obviously enough people for all the letters, but if we had enough people for each letter of the alphabet, the job would happen pretty quickly, and we'll get the results. This is called scale out, because instead of trying to just beef up one machine, we're actually adding more machines, so we're going out with more machines. And when we break up the data, that's called partitioning. So we're going to chunk the data up or partition it and give that partition to a single computer or machine. In the cloud environment, it would be a virtual machine. So you would have each of these people basically being a virtual machine, and they would do their work. Now, it's important that you don't duplicate any of the data when you do this, which you can't really do with a phone book. So when I give the A's to one person, nobody else should have any of the names that start with A. And the same with the B's and C's. It's important because otherwise you'd be getting duplicates in your output. So the important thing to remember about this is that in order for this to run in parallel, you're going to have to make sure that when you chunk up the data, you give a very discrete chunk of the data to a single machine to be processed. Otherwise, you can run into trouble. And if there's any challenge breaking up the problem in a way that can be run in parallel, you're going to have performance issues. It's going to slow things down a lot. So this is how scaling out works. And this is what Apache Spark does. This is what Hadoop MapReduce did in the olden days when that was a big thing. It's also what Snowflake does and many other big data platforms. In fact, even Azure Synapse uses this same sort of structure. Now, I simplified this problem to give the idea that normally Spark would distribute over the machines a very logical chunk of data, like by, say, zip code or people's last names, as I gave an example. But I do want to point out, don't count on that. In fact, that's not likely to be the case of how Spark would really distribute the data. Conceptually, it's good to understand it that way. It helps me at least sort out what's happening kind of under the covers. But generally, Spark is actually going to distribute the data by how many CPUs it has, how many machines it has, and try to maximize running things in parallel. And for that reason, it won't necessarily go by any kind of logical chunking. Now, the Apache Spark platform is great because it can interact with many open source and even closed source platforms. And as you can see here, we have things like MySQL and Kafka and Redis and Mongo and Cassandra, HBase. A few things I want you to take away from this big ecosystem of what Spark can work with. Spark is designed to work as much as possible in memory. Now, it uses RAM and it tries to avoid writing to disk. However, usually you're going to have to pull data in, and oftentimes after you've done a lot of processing and data wrangling, you may want to save data back. So when you're reading data or you're writing it back, you're generally going to be doing that on the legacy Hadoop HDFS. So Hadoop MapReduce is a sort of legacy big data processing platform, and while we're not using that directly as part of Spark, we do adopt the HDFS format, which is Hadoop Distributed File System. That creates a lot of resiliency and redundancy in the data, and it obfuscates that so that you can kind of look at it just like any other storage. I bring that up because you're going to see that a lot in Apache Spark, and even when using a cloud platform like Azure, under the covers it's storing it in HDFS format, or at least an HDFS API compliant format, so we can work with it as if it were true HDFS. That's a really important kind of reuse going on with Hadoop. The other thing I want to point out, as I mentioned, but I'll push it again, is that this platform and all the things you can do here are inherently part of Databricks because Databricks has Spark as part of a subset of its functionality. So a little more discussion about how does this work, Brian? I'm a little confused. How does this whole thing operate? Well, looking at the right, you can see that we have this driver program, right? The driver is, if you were using just open source Spark, you get a prompt. And you have a PySpark prompt, or you could have an R prompt or something that you can go in and submit requests. So if you had, for instance, the PySpark C prompt, we'll say almost like a C prompt, right? And you type in your command, that's where you're entering. And that driver, in order to give you that functionality, has to be on a computer somewhere. So that's called the driver node, and you would submit your request. Now, something has to get the team ready. You remember before that group of people, somebody has to say, okay, guys, got it. Melanie, you're going to do this, and Charlie, you're going to do this. That's the cluster manager. The cluster manager is going to coordinate the work going on the team, and the driver is the one that's submitting the work, saying this is what I need you to work on. And you can see when we get to the worker nodes, there's a separate node and there's cache on every node, and that is because it wants to keep everything it can in memory, and if it can reuse things, it can be cached also so that it can hold it there and go back and reuse it again, as opposed to recalculating what was there. You'll see these things called tasks in the box, right? So you can see here tasks. And so the idea is to have as many tasks running in parallel. And at the bottom, you can see data sources. You see HDFS, but also it might be some sort of SQL data source, NoSQL, or any other kind of storage mechanism that it may be leveraging. The idea behind this is massive parallel processing. In other words, you want to spin up and have as many computers working at the same time, with as many core working at the same time, so that you can get all this parallel work being done concurrently and get the job done faster. Now, I bringing up this little diagram to the left over here because this diagram you see on the right is a little oversimplified. On a worker node, that's a virtual machine. But a worker node can have, a VM, can have many core. It depends on how big it is. It could have a lot of memory, or it could have very little. It can have a lot of core, or it could have very few, meaning CPUs. So if we look over here, it's a little more accurate in that you see the driver program just like over here. The cluster manager is communicating to the worker nodes, but in the worker nodes, you see executors. So you have an executor in this one and this one. This is also a little misleading because a worker node can have many executors. It can have one or it can have any number of executors. It depends on how many core it has. And the executors actually run the tasks. So the tasks are the lowest level unit of work. So we have the worker node, which is a VM. We have any number of executors, which are running things in parallel. And within the executor, it's going to be running tasks. Again, trying to maximize parallel execution. So there's a lot of work going on, and it's a little too much, I think, to keep in your head. You don't really need to. The only time this becomes an issue to you is when you get into performance issues and you're trying to figure out what's the best way to allocate how many nodes you're going to need and how many executors and what kind of resources you need. In Databricks, I think most of the time you're not going to have to worry too much about that because it can ratchet up and ratchet down the Spark cluster as needed. So let's talk a little more about Apache Spark. This diagram gives you a kind of a snapshot of how Apache Spark looks. When you see this Spark core engine, that area, that is as old as it gets for Spark. That was the original pre 1.0 release of Spark. I think it went up to about 0.9 or somewhere, I think. And that was really bare bones functionality. It could only use RDDs. It didn't have all those fancy services you see above it. So it was the basics, but very quickly other services got released. So we saw SQL, really important. Early on, the people that created Apache Spark, which is the Databricks people, realized we really need a good way to communicate to Spark. It used to have to use this interface called RDDs, Resilient Distributed Data Sets, awkward to work with, not intuitive, and hard to understand what you're even trying to do, and not optimizable. So instead, they introduced this whole new way of communicating called Spark SQL, which is just the structured query language we all know and love. Uses an ANSI standard version of Spark SQL, so it's not really proprietary. The other service you can see here is Spark MLlib, so it supports machine learning. Then you see Spark Streaming for streaming processing, like you could have Kafka streaming into this. And if you want kind of a graph API here, the GraphX, that allows you to create sort of a network view of the data. So you have batch processing, interactive SQL, so you can work directly interactively with the cluster, real-time processing, streaming, machine learning, deep learning. What I want you to take away though from this also is, in this world where we're hearing so much about AI and it's the big thing, Spark was designed from the very beginning to support AI. It's kind of what it was built for. So it's positioned really well to go into the future, and I think we're going to see Databricks grow with that. They've invested a huge amount in AI and they were already well positioned. One of the reasons they're so well positioned is because a core and most popular language to work with Apache Spark is Python, the Python language, and it has a special library called PySpark. Much of the time when you're working on Spark with Python, you don't even really think much about the PySpark library because it seems to just work. And they even obfuscated when you're going from Pandas, which does not understand Spark and will not scale out. They created a Pandas API on Spark so that what Pandas understands, Spark can understand. So they made it even easier. The bottom line is Python is a first-class language on Spark, and so it is on Databricks, and you'll do a lot with that. And I want to point out also that Python is a really great language for doing any kind of AI or machine learning. But you can also use the R language if you like. There's two different libraries available for that, Spark R and Sparkly R. You can use Scala. Now the original Spark platform was written in Scala, which is a sort of derivative of Java. But it's being replaced, at least on the Databricks side, pretty quickly, I will say, with C++. So we'll have to see where that goes, but in order to get better performance, Databricks started replacing much of the engine with C++. But generally you can think of this as a Scala platform still. And so Scala is a language you can certainly use when you're working on Spark. And since Scala is really riding on top of Java, you can also use Java libraries. And as I mentioned, since you have Spark SQL, you can use SQL. So these are the primary languages on Spark. Is that the only languages we could ever use? No, because Spark is actually designed to allow people to write around the API and add additional languages, I would think fairly easily to it. But at this point, these are the core languages most people are using. Now, one thing I didn't talk much about is the resource managers. In the beginning, it used what Hadoop used, Yarn or Mesos or one of these, and it has its own built-in standalone scheduler. But more and more, Kubernetes is becoming sort of the resource manager for Spark. Something that is technically not a service in Apache Spark, and something I didn't talk about in my other series but is really important, is something called Delta Lake. Why is that so important, Brian? Because believe it or not, when Spark first came out, it did not have any way to update data, which seems kind of crazy, right? You could bring data in, you could slice and dice and query and have a lot of fun. But if you suddenly said, okay, I've got all this data that represents my entire list of, say, customers, I had no way to update the data in there. It didn't support the idea of tables that I could insert and update. I could bring in a completely new copy. I could try to do some reading and munging until I could get something and write a new flat file. But it was very flat file orientated, and so it was very limited, and you could not do a sort of scaled out data warehouse. And this is really surprising. I think most people didn't realize, kind of stuck in there in the fine print. So a few years ago, Delta Lake was added, and Delta Lake is a way that you can create maintainable files or tables within Apache Spark, but beyond Apache Spark as well. So Delta Lake is a sort of new format that, as long as whatever service can understand how to read and write to Delta Lake, then it's good to go. And what is such a service, Brian? Well, I'll make one reference to it other than Databricks and Spark itself, but you can use Delta Lake with Fabric, and Fabric supports Spark as well. So Delta Lake, in fact, has become sort of the unified standard underlying Fabric. In order to use Databricks, we have to use a cloud environment. Therefore, in order to use Databricks, we have to log into whatever cloud provider we use and allocate a Databricks service within that. In this case, I used Azure because that tends to be the cloud service I use, and I went in, and I'll do this in a later video to show you specifically how to do this, but I created a Databricks workspace. Once you create it, then you launch it and you go in and you can work with things and do all your fun querying and whatever you need to do. But I wanted to kind of walk you through, what does this workspace look like? First thing I want to talk about is the fact that even though we're saying workspace, it means multiple things depending on where you use it, and this is a little confusing. So within the cloud provider, we create a Databricks workspace, which simply really means we're creating a service we can access to do Databricks work within that cloud provider. Once we get into our user interface, which we are here, then we have this other thing we see called workspace, and that's really like a storage folder. So workspace becomes a place we can store things under a folder system. We can have code, we can have data, we can have notebooks that we're working with. So that's kind of the idea to this. And on the right, you can see it's opened up a workspace, and you can see it's showing a folder, some notebooks, even a query that I saved. Now all of this, you can see on the right, it says all of this with the arrow is running on Apache Spark, and this whole area is the user interface within the workspace for Databricks. So let's take a look at these sections, because this is another area where my original series was very different than what you see today. That was done back in like 2020, and since then Databricks has done a lot of things to enhance and expand and even change the user interface, which can make my original series a little confusing. So the first thing that they kind of changed around was to separate into different areas the types of things you can do. The most commonly used services are at the top. So if we want to create something new, we just click on the new button and create something, a new notebook. The workspace, you can see here highlighted, that's our folder storage area. And it's a good way if you want to find like a certain notebook we're working on, or work on some code. Typically we can go to the workspace. I tend to go to that a lot to find what I'm looking for. There's also a recent thing, so anything I've recently worked with, I can find it quicker there. There's a catalog, which is when I have tables that have organized data similar to a SQL table. The catalog allows me to go in and look at that and see what's available. We have workflows, which are really like job runs, orchestrations, so that's what workflows are. We have compute, which is where we create our Spark clusters, and marketplace is an area where we can bring in other third-party services that can integrate with Databricks. Like Fivetran is one example. So if we are a data engineer, we're going to use that first section quite a bit. In fact, that's probably where we're going to be most of the time. This other area is relatively new. It barely existed back when I first did the series before, and this is what I call the SQL warehouse area. I'm going to tell you a secret. I think the main reason they created so much around this is to compete with Snowflake. Snowflake is a scaled out platform, runs only on the cloud, much like Databricks, but it focuses a lot on the sort of emulating a relational database look and feel. So if you're comfortable with SQL Server Oracle, then you're going to love Snowflake because it's very SQL focused. It looks like that. And you go in and primarily use SQL to query and run things, and it's great for analysts. So this SQL warehouse section is something that I think is mainly focused on that, not something that data engineers are going to be using, I think, a lot. So in my series, I won't talk a lot about that SQL section, but mainly that's for running SQL queries and running them and testing them and things like that. Now, when I get to the data engineering, you can see this thing called job runs, data ingestion, Delta Live tables. As you can tell, that's a lot of stuff running around creating pipelines for ingestion. Most of the artifacts you would use or objects would be coming from up here, like your workflows and your notebooks would be in the workspace. But under data engineering is where you would execute some of those things and set up some Delta Live tables. Is a fairly new feature that is sort of like automatic ETL generation and maintenance and monitoring. There's a lot of things in there. And we're going to see a lot more of this workspace as we get into other videos. So let's take a minute and talk about the Databricks workspace objects. This is really a small subset of the actual objects, but it's the main objects you're going to see and need to know quite a bit about to get proficient with Databricks. First one is clusters. Now Spark works with what I talked about. We already saw the diagram, the cluster, and it does all the work. But Spark is really designed to be like one cluster at a time. You create it and you're focused on one cluster. When you're done with the cluster, you have to delete it. It's not designed to like run lots of different clusters for different types of needs. And that can be a problem because a lot of times, especially if you're working with teams of people, some people are going to have heavy workloads that require big clusters. Other people are going to want small clusters. And to satisfy all these different types of needs, you need like a cluster UI management monitoring sort of service. And that's what Databricks provides really nicely out of the box. So you get that. And you can pause clusters really easily, something not so trivial if you're in Spark. So again, you get a nice add-on with your clusters, and you're going to have to get very familiar with how to create, allocate, and pause, and even add libraries to clusters so you can do your work. Folders, just so you're aware of them, but in the workspace you have folders, and you're going to want to create folders that make sense for your given architecture so that you can find things. So I typically would have folders within an app that hold, say, the notebooks. If I have common notebooks that are sort of reused across different work, then I might put like a utilities folder. You also might have certain configuration files or something. So you want to make sure you think of your foldering system under your workspace. Notebooks are typically the way you're going to write your code. Notebooks are very powerful. Now these are Databricks notebooks. They're very specific to Databricks. Really powerful, nice notebooks. You can do pretty much anything you want to do with those. But recently you can also go beyond notebooks and like write Python modules, packages, whatever you want, and call them from a notebook, or just run that standalone if you prefer. Libraries, well, you got to use libraries, right? So whether it's R or Python or Scala, good chance you're going to want to bring in libraries. Now out of the box, Databricks does provide you with a lot of the standard libraries, especially for Python. So you're not going to likely have to import many libraries. But if you have some more esoteric library you really want to bring in, you can do so within Databricks. And something called jobs, workflows, I kind of use these interchangeably. Workflows are your orchestration. So you write some sort of code. It could be you have one notebook and another notebook and another notebook, and they need to run in sequence to accomplish a task. So chaining that work together is called a workflow, and then running it, I would call the job. So we're going to have a job that does all that stuff. When you schedule this workflow and you say you want to run it like every day at 2 o'clock, you would set up a schedule and it kick off. And there's monitoring you can do and go in and look at previously executed jobs, see if anything failed, notifications. So jobs and workflows are really an integral part of running your data engineering work. And we'd be remiss if we didn't talk about security. Now, security is one place where you can't really stay self-contained. You're going to have to interface with the security in the cloud environment you're in. And Databricks supports certain features that allow you to do that in a sort of consistent way. So if you were in Databricks and you needed to access Azure Key Vault, for instance, you would use what they call secret scopes within Databricks, which provides a sort of general API that can call out to the hosting cloud environment and do things like get a secret key. So these things are really important, and when you're doing data engineering in any cloud environment, security is going to be a big chunk of your work, and it's going to be a fair amount of maintenance to keep that all straight and make sure you get it right. So just to kind of highlight, like again, what's the difference between Apache Spark versus Databricks? So you can see here, 2 people camping, there's a tent in the background, and the name of the tent is Apache Spark. This is pretty basic. They got a place to stay, yes, it'll keep them dry if it rains. Not so good if it gets to be 10 below zero. They're roughing it. Whatever they need for food, they got to bring it. There's no like water supply, there's no electricity, no luxury here. It's the bare bones. And that's really what I think Apache Spark is. Spark is a good place to start. It's great. You can use it with obviously containerization and things, but it's really basic. But think of on the right, Databricks here is more like taking Apache Spark, which is that subset, but now you have heating, electricity, running water, a kitchen. There's a restaurant in this hotel, we'll assume, concierge services, on and on. This is like luxury service. Now, why would you choose one or the other? The Apache Spark is free, and you can run it on-prem. Good place to learn things and everything, and people do use it. But if you're a business, and this is happening more and more with businesses, like we need to start getting value from our data now. We can't wait. We don't want to spend 6 months learning stuff and building stuff out. We need to start producing immediately. Then Databricks is really a good way to go. And in the end, you can save money using Databricks over Spark. And I don't work for them, so I'm just telling you, you can save money because you can manage your resources pretty well in Databricks. You can, for instance, say, when my cluster is done doing something, after so many minutes, turn it off, and you don't pay for the clusters. Most of your cost in Databricks is going to be the resources, the compute you're using, not storage. So that's where it can save you a lot of money. But those are the 2 differences. If you're on the cloud environment, I would lean definitely towards Databricks. If you're on-prem, all you can really use is Spark. So wrapping up, as I mentioned, this is a new series. I've got to stick to this so I can get the rest of these videos out. But in this one, I talked about the fact that in this series, I'm not going to be covering Apache Spark as a separate topic. I'll incorporate that in as I talk about Databricks. And while my original series is out of date from the UI standpoint and some Databricks services, most of it is still applicable. It hasn't so much changed as much as so many new things have been added. We talked about what is Apache Spark, and we learned that Apache Spark is a big data open source platform that scales out, right? Uses any number of machines to run data pipelines in parallel. We learned that Databricks is a company founded by the people who wrote Apache Spark, and they not only maintain the open source Apache Spark to a large extent. I want to say 70 or 80% of the code in Spark seems to be getting maintained by Databricks, which is really good. I give them kudos for that. But Databricks adds a lot of stuff on to what Apache Spark does. It only runs in the three major cloud environments, so AWS, Azure, or GCP, and it has a lot of services for development, deployment, and building solutions. The big takeaway is Databricks is sort of a jump in and just start using it immediately. Everything's a platform as a service. I would really say it's more of a software as a service with the platform underneath it. So when you want to get up and running quickly, Databricks is a good way to go. Talked about scaling up, scaling out, Barry the weightlifter, and I think it's enough said that the idea is we're breaking up a big job of all this data we need to process, and we're by breaking out the data into chunks and then distribute it among many machines and running things in parallel, we get it done faster. We talked a lot about Apache Spark versus Databricks, and I think I've beaten that to death, so I hope you get the difference, but if not, post a comment or question, and I can answer it there. And then we did take a quick look at the Databricks workspace and the user interface, and it's a really good place to develop things. I've used it a lot. It does take some time to get used to. And that's it for this time. Please like, share, subscribe, and until next time, I'm pulling for you. We're all in this together. Thank you.